Jay here from Jay's Vintage Junk, and today we're going to be taking a look at this. What we've got here, this is my Zenith Data Systems, what's the model on this? I can't actually remember what the full model is, but this is a Zenith Data Systems 286 from mid-1980s, around about 1986, 1987. I did a video on this computer a few years ago now, probably about 2017, 2018, around about that kind of time, where I dug this thing out of storage and got it up and running again, changed the BIOS battery in it, got it booting, got the hard drive working and everything, and pretty much after that I put it basically back into storage. It was sat up in the attic for basically since I did them videos. It got dragged down when I redid this room and stuck under a workbench down there, and actually a couple of months when I started working on the Amstrad, the Amstrad PC 1512, I actually pinched the 5 1/4 inch 360k floppy drive out of this, and I actually pinched the Hercules card out of it for when I was messing about with additional monitors on that, and when I wanted to get a 5 1/4 inch disk drive booting on it. And it's been basically just sat under my other bench back there since then. Now, a couple of days ago I started playing about with my Apricot. I really want to get to the bottom of that problem, the issue with the Apricot not booting from floppy disks, because that's the only thing I need to really sort out on that Apricot, and then I can, I can build it all up into a nice system. I can actually have it set up somewhere here where I can actually play about with it and mess about with it properly. So anyway, as I was fiddling about with that, I thought I'll borrow the floppy drive card out of this, because I tried another floppy drive card in it and that wasn't making much of an improvement. So I opened this thing up to pinch its floppy drive card, and we've got a horror. I worked on this not that many years ago, and I changed the BIOS backup battery in it back then, and that battery that I fitted has leaked, and it's done a lot, and I do mean quite a lot, of damage in this computer. I'm a bit miffed really. It's my own fault. I didn't use a brand new backup battery. I had one in a drawer which was a used one, but good, tested, full voltage. There was nothing, it seemed absolutely perfect, no signs of leaking on it, no signs of corrosion on it. Like I said, when you tested it, it was perfect for voltage. It was identical to the one that actually had failed in this computer and not leaked. That's what I will say. The one that I replaced that was originally in this computer, there was no sign of leakage on it at all. It just was flat. The one that I put in there was an identical battery, same brand, same everything, just full, working. It had a good voltage on it, and like I said, it has leaked and it has done quite a lot of damage to the inside of this computer. So what we'll do, rather than messing about with my Apricot, which is what I was planning on doing on this video, let's see if we can do some repair work to this thing, at least in this video. I'm not planning to get this fully sorted again in this video, but at least in this video let's treat the corrosion, let's have an assess of it and see quite how bad it is. It does look pretty bad. So anyway, I'll get the camera set back up so you can actually see down into the computer, and we'll take it from there. So back in a sec. Right, okay. Let's see how bad it is. Okay. As we can see, it's pretty bad in there. Can you see all this corrosion here? There was none of that corrosion in the computer when I put it away. All this corrosion has been caused by the leaking battery. I did actually remove the battery itself, but here we go. I mean, it's affected this back plate here, that's all corroded. The power supply itself down this side, that's all corroded. What I'm most thankful for is that the two cards, the processor card and the I think it's the RAM card, seem to be okay. I don't think they've actually got any corrosion on them. We'll take them out actually now, and we can have a quick squiz at them before we actually get down to this this bottom board, which is the real problem in the computer. Right, let's whip these out, and then we can have a proper look at them. Now let's put my anti-static on, just to be on the safe side. This is the CPU card. Ooh, I think this might have had a little bit of this might have bought it a little bit. So we can get this out unscathed. There's something stopping it there. Ah, there we go. Oh, I think we may have actually got away with it on that. I can't see any corrosion here along the edge connector. We've got the BIOS ROMs there. That's the CPU there. I think we've got 1/2 meg of RAM on there. I think that's about right for that card. Yeah, CPU and memory board, and the other board's the I/O board, I think. But it only has 1/2 meg of RAM, this as well, which is a bit of a downer, because you need an expansion card to give you any more RAM, and they're now horrendously expensive, and I don't have one. So at the moment this is limited to 1/2 meg of RAM. Right, yeah, this is the I/O board. Hopefully, if that board hadn't received any corrosion, this one should be absolutely fine, because obviously this is further away from the damage than that one was. Right, let's see if we can get you... dear me. There we go. There is the there's a little bit of discoloration there, but it's not like green slime or anything. It's not acid damage, fortunately. It will clean off with just some IPA on it, that, and a cotton bud. But yeah, that seems in reasonably decent condition. That's our I/O board anyway. Like I said, that should be absolutely fine. So I'm hoping that these haven't suffered at all. It is just, it's this which is worrying me, because that looks pretty horrendous down there. So what we will do, we'll get this disconnected, and we'll get this board out. Even this power connector here seems to have suffered. Yeah, that's pretty horrendous. I wouldn't believe a battery would cause this much damage. Right. Let's see if we can get the only good thing is that this is the one piece of the computer which is reasonably replaceable. I could just get an industrial backplane, an industrial ISA backplane, and be able to replace this this backplane board. I would obviously have to rewire the power and everything to get that to work, but that, if this is beyond saving, that's what I'd have to do. I do rather like this this computer. It's one of the larger systems I've got, and you can't have many large systems. Like I say, I just don't have the space for them. I have quite a few anyway. It's a bit of an iconic 286 computer, this. Not quite as iconic as actually like the IBM. original IBM AT. What was that? The 6170 or something like. I can't remember off the top of my head, but it's not quite as iconic as that. But this Zenith system, there was a huge quantity of them apparently bought by the US government. And basically, if you look at any research papers that involved using a computer to like log data or something like that in the 80s or early 90s, it usually mentions somewhere about a Zenith. I can't remember what the model number of this is. I will put it in the title of the video though. But it basically mentions this computer as the computer that was used for like data logging in the experiment or whatever, because the US government bought so many of them. It was some big drive in the 1980s for them to buy American rather than buying, you know, like cheap knockoff Asian, you know, like Korean built and Japanese built systems, to buy American instead. Now here's where we're going to have an issue. I've got all the screws out apart from that one and that one. I may have to resort to a Dremel or something and actually Dremel the heads off those, because I don't think those are going to want to. No way. That one, there's just no head left on it. The head's basically just crumbled to bits, and that is so tight. That's not going to come out easily. I'll try a bigger screwdriver before I give up, but I think we're going to struggle there. Just bear with me a second, folks, and I will see if I can find something to extract those two screws with. So back in a sec. Right, some good news. I've actually managed to get both of the screws out. And there's one, and there's one just lying. Oh, that's still hot. Ow, that was hot. Basically, I was going to try. I tried unscrewing them, and they were not undoing. They were not unscrewing. So I thought, right, I'll Dremel them. Unfortunately, I realised I couldn't really get in with the Dremel tool without risking damaging, you know, like that connector there, or chopping into something. I thought, right, next best thing I can do, I'll drill the tops out, get them out that way, and then I can get some mole grips on what was left of the shaft and wind them out that way. Fortunately, just the process of actually getting the drill like that and drilling into the top of the screw loosened it enough that the screw actually moved slightly. And I was able to get, basically, once it had moved, because I've drilled into the centre of it, I was able to get a pair of pliers like that, grip onto it and turn it, and I've managed to wind both screws out. So we still have two clear holes there to put new screws in. That capacitor, unfortunately, just fell off the board as I was doing it, so obviously that will need replacing. I'll throw that to one side. And hopefully we can now lift the actual main backplane board. Well, it is more than just a backplane board actually, because it does have the keyboard. It does have the keyboard connector on there as well, which we'll have to sort out, or else we're not going to have a functioning keyboard in this computer. And yeah, we've got yet another screw we need to see if we can possibly get out as well. Let's see if I can just manipulate. Obviously, we'll have to change that. I'll have to change that ground connector anyway because it's severely corroded. But I think we might just get that to... look at that. That one, it was at least turning and coming out. There we go. Let's get that disconnected. I don't have to worry too much about anti-static, obviously precautions. Now the static sensitive parts of the computer are out and to the side there. I will put them in an anti-static bag very soon. Right. Oh dear, look at this. Look at the amount of corrosion we've got in here. It really has done an absolute number on this case. But we'll tackle the case itself in a separate video, because all this is going to need treating and protecting. Dear me, this has made a right mess of it. Oh, right. Let's get them screws out of here so they're not going to cause a problem. In fact, what I'll do is I'll reset the camera anyway, so we can get you down and we can actually have a look at the damage on the boards properly. So back in a sec. Right, okay, we've got the board out on the actual bench, and fortunately, at least for one fortunately, is that all the damage seems to be localised to this area here. When we actually look at the ISA slots, there's no, apart from this end one which has got a few little signs of green on it, I can't see any other creeping corrosion on any of the other ISA slots. It is all just localised to this part of the board. Obviously the battery used to be there, and the battery literally fell off the board. It's actually, you know, it used to be, it wasn't soldered to the board on this, it actually had a little battery holder on the board there with the battery in it. It is bad though. I won't deny it. This is really bad. First thing we need to do anyway is clean this up. There's no point going any further or crying about spilt battery acid if we don't actually clean this up and see exactly how bad the damage is. And what we need to do that with is some white vinegar. This is just really cheap, 5% distilled white vinegar. It's about 60p, or at least when I bought this, which was probably 2 years ago now, it were about 60p or 59p or something like that, so it's dirt cheap. And believe it or not, you want an acid to neutralise this, because we all call it battery acid. It's not. It's an alkali. All the batteries, like lithium batteries and alkali batteries used in these old computers, obviously you need an acid base to neutralise an alkali, and this is a good cheap acid base you can use. I'll just pop the top off here. I thought the top used to come off a bit easier, but obviously not. Come off. This is where I learned this isn't the one that I use for this. And this is the one that was in the kitchen. Yeah, I can't get the lid off that. Oh, never mind. We'll just deliberately dose it anyway. I would actually expect this to have fizzed up a little bit more, but it is just starting to fizz. Yeah, that's starting now. Basically, it starts to fizz up as it neutralises the. You can see it happening there. You can see when you look in there as I agitate it. Oh yeah, look at that fizz there. You can see how it's fizzing up around that connector as I just work the white vinegar in. We're probably going to have to change that connector because I'm sure the corrosion will have really eaten into that, but at the moment the idea is to work this into the board and neutralise as much of that alkali that we've got all over the board as we possibly can. Getting this side here. I mean, any components around here which are really corroded we can just change. There's nothing, you know, there's no custom ICs or anything on here. There's nothing that isn't easy enough to get a replacement for and replace. Our biggest thing is going to be really trace damage. How much actual trace damage has been has been caused by the corrosion. I'm sure there will be some. I'm sure we're going to have to do some repair wires before we can get this thing working again. Right, so look on the other side. In fact, we got really, really lucky. It looks like there's hardly anything. A little bit up there where it's come through. A little bit of corrosion down there on where the battery contacts are. But apart from that, actually that side of the board, this is a good thing at least. This side of the board does not look like it's suffered any really, really serious damage. I'll get some Q-tips out and we'll have a quick clean up. And that really stinks when that stuff starts to react as well. Very like a strong metallic-y smell. We'll just use a pile of Q-tips to clean off what we've just done here. You can see how bad that is. That's completely rotted out the solder that was in that hole there. No, that side of the apart from there's one trace up at the top there that looks like it might have suffered a little bit. But I'm sure the worst of the damage is going to be on this side here. In fact, what I'll do, I'll just spend 10 minutes just cleaning the worst of this off, and we'll come back and we can have a proper look at this part of the board once I've actually got all the crud off. As you can see, it's pretty filthy. It's literally just a case of going along here now with the Q-tip, getting up as much of this as we can, and then we can actually assess exactly, like I said, what we've got left on the board. So back in a sec. Right, okay, we've had a good 20 minutes or so with, as you can see, quite a few Q-tips, and I've got the worst of the corrosion off. In fact, let me see if I can zoom you in a little bit. Right, let's have a look at that. Right, there we go. So this is basically after a good where are we? There we are. Can get you better in shot here. There you are. That looks a little bit better, doesn't it? I don't think I can come any further in. Oh, yes I can. Right, that gives you a good idea of quite how bad this board is. Let's start here. Right. So we've got obvious damage down here. This is where I've just been scraping at it. I thought we had some breaks there, but actually the copper underneath doesn't look bad. What we do still have is all this it's like ferric oxide corrosion, and the only way I've found to actually get it off is literally with a little screwdriver here. Scrape at it like that, then a little bit of IPA, and then you can slowly, as you can see, you can slowly scrape it away like that. So it is literally a case of agitating it with like a metal tool or something. Possibly a plastic tool would be better. And then it's getting some IPA, rubbing, and as you can see, you can slowly get it away. But there's a hell of a lot of corrosion still on here, which I need to remove. Oops, kick the camera. That connector is going to have to come off for cleaning. I can't even get a Q-tip down right into the bottom of there to get all that clean. There's loads and loads of like corrosion down in the bottom of that connector, so that's going to have to come off. In fact, basically everything on this board, you get you zoomed out. Oops, wrong way. I've got a bloody remote control and I still managed to get you the wrong way. But essentially everything on this board from here onwards there, I'm going to have to strip off the board. So that ISA connector there, that capacitor, all the LEDs, all the resistors, that connector, the keyboard connector, all the capacitors and diodes around there, all that's going to have to come off the board. Then we can actually really see what damage we've actually got to the board. All these resistors are going to need replacing. Let me get you zoomed in. I mean, they don't look too terrible straight there, but all the legs are really seriously corroded. It's not just a little bit of surface rust, they're actually literally rotten. Now I think there used to be an actual wire that went between that resistor and that diode there. Hang on, you can't see what I'm showing you, can I? Let me get you up. Oops. There we go. You can see here we've got a little diode there and a resistor. I believe there should actually be a piece across there with them two soldered together. That's actually completely dissolved. The legs of this capacitor to the point where, again, they're just rust. To be able to clean it properly, that's going to have to come off. We'll probably put a new one on. Ditto with all these LEDs. I've cleaned round them best I can, but there's so much corrosion around there. All them are going to have to come off. Same with these diodes here and there. These, oh, those are chokes. We've got L100, L102 and L103 there. Those are going to have to come off and be cleaned up. There's some bodge wires. Let me get you over to the keyboard connector. There's obviously been some rework or some bodgery gone round here. It's probably factory. Between there, there's a capacitor been put in there. There's a piece of tape been stuck down so that can't short to the board. So what I'll have to do is I'll have to photograph all this and then take all this apart very carefully. Then we can have a look at the board underneath there. Basically, I think that's going to be the first port of call. Next video we do on this, which is going to be fairly soon, because I really, like I said, I weren't planning on doing a video series on this computer, at least just yet. It was going to be coming up with a for a video eventually, but I wasn't planning it on just yet. But seeing I've seen this damage, I can't just leave it like this, it'll get worse. What are you doing, you camera? I am not making the camera zoom in like that. The camera has decided to zoom in completely on its own. Let's see if we can get that to zoom back out again now. Come on. Here we go, we're coming back out. Are we coming back out? Oh, there we go. I don't know what happened with this camera then. It all of a sudden just decided it wanted to zoom all on its own. Well, it seems alright again now. Anyway, where that got me distracted, where was I? So basically in the next video we'll be taking the ISA connector off there. We'll be stripping all this part of the board down. We'll be doing any repair work we need to actually do on the board, and then we'll be repopulating all this part of the board. We'll have to do some work on the power supply to actually make sure we can get a good connection between that and the power supply, and at least then we can get this and the main cards fired up on the desk and make sure everything's working before we tackle all the damage to the actual case, and we can make it back into a nice workable computer again. Anyway, I'm going to leave it there for now. Like I said, this wasn't the video I was really planning to be making. I was hoping to be working on that issue with the apricot and getting the apricot to actually boot from a floppy disk. But this is more pressing, and it goes to show if you're into your vintage computers, whatever you do, keep your eye on your backup batteries. I mean, that's not the type of battery I would really associate with one of the leakers. It's not a NiCad cell, a rechargeable NiCad cell like we had on the A500, Amiga 500 Plus, or various other computers, or then horrible little cells they used in the Acorn Archimedes and stuff like that, which tend to like to leak. These aren't known as a battery that I'm particularly known for being a leaker, but obviously when they do leak, I mean this is a lithium battery, it's a 3.6 volt lithium battery that should be in there. I'm guessing this is what all the white stuff that was all over the board is. It'll be lithium salts as the lithium degrades. I weren't sure that, I didn't know there was going to be something particularly nasty and corrosive in there, but as you can see, it's done a hell of a lot of damage. Like I say, I'm going to leave it there for now. Like I say, in the next instalment, we'll be clearing all this up and seeing if we can make right to what's gone wrong. So, hope you enjoyed this little video, this little introduction to the project. So, thanks for watching and goodbye.